we've kind of trimmed it down, less marketing for you guys so you guys get into the substance of the presentation faster. So we're a provider for IT solutions. We're headquartered out of Alpharetta, Georgia, which is a suburb of Atlanta for those of you who aren't familiar with that area. We also work in the Northeast as well. We specialize really on 3 primary solutions. And they're around cloud platforms, and I'm sure everybody's tired of hearing about the cloud, but this is the traditional virtualization that you're all well aware of, the VMwares, the Red Hats, the Hyper-Vs, etc. But taking it into the cloud, the private infrastructure, and then also into the public cloud, and finding ways to hybridize and to leverage the economies of both and provide manageable solutions for your environment and your particular business needs. So we do everything around that kind of a platform as well. And Gigamon kind of falls into this category for helping you to manage your complex environments. And I'm not going to steal their thunder. They're going to tell you all about their product here in just a little bit. But the next tier of solutions we work with is our data management. This is everything to do with the life cycle of data, from the the need for capacity, for the creation of new data, all the way through archival and replication and DR, business continuity, et cetera, all the way until you decide you either are going to just slap this on a tape and keep it forever, or you can delete it. So we help with that full life cycle of solutions. And then our third category is around support services, and this is kind of a differentiator for us. We have our own help desk that grew out of the old Sun Service Manager program, which allowed us to take the first call for support for our Sun customers and provide that first level of escalation and resolution, and then pass off to the appropriate parties afterwards. And while Oracle has killed that program, unfortunately, during that acquisition, we still maintain that service for our customers today, and we've added to it services, more traditional help desk services for end-user support. We do support for ISVs and ASPs that are too small, really, to support their own help desk. We'll get to know your product and sell your product, or excuse me, support your product for you, and then also customized solutions for third-party maintenance and such. We're very proud of the awards we've received. A lot of these awards are directly related to our help desk services. We get recognized for that every year. You see the Stevie Awards, the American Business Awards there. But also we are a multi-year recipient of the CRN Tech Elite 250 and the VAR 500 list there, the Solution Provider 500 list. These two lists are similar to the Fortune 500, but specifically for the value-added reseller community. And the Tech Elite 250 is even a little bit more, exclusive than that, in that they've looked for the companies to really have what they believe to be a vision for IT and its path forward today, and companies that are providing good solutions in that space. And so we're very proud of all these awards. And we partner with a number of people. You see Gigamon's obviously on that list, but HP and IBM, Oracle, VMware, Citrix, Hitachi, Symantec, Red Hat, they're all very critical partnerships to us. We maintain very high levels of partnership with each of them and certified staff that are able to come in there and understand your environment and work on solutions for you. So today, why are we talking about Gigamon? So there's a few bullet points up here, that things that we kind of take away from what we think Gigamon offers our customers. And take a quick minute to look at those, because I want you to focus on those during this presentation. Really learn what these things mean for you and your company, because this is a unique solution. This is a solution Gigamon really has this space to themselves. And it's a very key differentiator for them, what they can do. So with that, I'm going to turn it over to Steve, and we'll give you the keyboard here, Steve. There you go, Steve. I think you should have it now. Or excuse me, no, here you go.
Not yet, okay.
I apologize, everyone. There. Now you got it, Steve.
Okay.
and we can see it.
Great, thank you. So again, thank you to Unitiv for partnering with us and having us on today. We're very excited to have time to spend with you and tell you about Gigamon. My name is Steve McKinney. I'm a systems engineer based out of Maryland. Here we go. So what we're, again, if you don't know much about Gigamon, we were started back in 2004, and our vision is pervasive visibility of communications for your infrastructure. So we're going to add tremendous value by giving you visibility into your traffic. So some of the challenges here in 2012, just generically, we're moving from fixed to mobile. Our servers are moving to virtual. We're dealing with cloud infrastructures, and it used to be we were only dealing with just data. Now we're dealing with all kinds of traffic. So the amount of data is exploding, and again, not just data. We're dealing with voice and video. So just very challenging at that layer, and certainly corporate resources to employee resources, things that are being brought in-house sometimes, iPads, iTouch, those sort of things that you want to do mobile. So very challenging, and we're still expected, right, to provide visibility to that information, who, what, when, and where. So how does this affect you when you're trying to do that? Some more specific challenges. A lot of times we see different groups, right? We have security group, network performance, application performance, network forensics, and analytics. There could be several others. Each of these groups has tools that they use, and they have needs that are usually unique to that group. But one thing they have in common is they all need access to the traffic. And when I say traffic, we're talking about looking at packets that are going across your IT infrastructure. So each of these groups, to support this need for their tools, is going to require access to the network. So again, each tool is going to have their own needs, and not only to complicate things, we have to deal with the mobility of these points where you're going to access the network. We have to deal with the mobility, being able to move around as the traffic moves around. So you might have to be pretty quick to do that, and also cloud. So there's not just one place where you can tap into the network and get this traffic. It's constantly changing, and we have to change with it. Now, when we're dealing with this, the current state is information's missed because, again, servers are popping up in different places. Maybe they weren't there last week. Now they're in a new place. The operational complexity, and as well as performance, right? There's also a lot of 10 gig links being fired up, and a lot of the tools that people are using in these different groups are still 1 gig tools. So definitely some problems that hit home, and these groups oftentimes are not necessarily sharing this type of information when it comes to getting network access for their tools. So what Gigamon's providing is a visibility fabric. So instead of each group getting network access for the traffic to support their tools, Gigamon will be a layer in between the IT infrastructure and the tools. So this way each group all they need now is access to the visibility fabric, which is really going to help us in all those areas with operational complexity, performance, and there's going to be a tremendous value provided to all of these different groups and the organization as a whole. And it's going to accomplish that at lower cost. Okay, so that's at a high level. If we look very specifically at a typical problem, one of the bullets that Craig put up was span port contention. So this is a very simple example of span port contention. If you have and span is a Cisco term. If you have a Cisco switch, it supports 2 span sessions. So those could typically be feeding some tools. So here we have one with an IDS, one with a web monitor, If any other groups need to get their tools to have access, those span port sessions are now occupied. So real simple, with a visibility fabric in the middle, we would feed these span sessions into the visibility fabric, and then we could connect as many tools as necessary. So again, a very basic, simple example of one of our bullet points, span port contention. Along those same lines, your tools are going to need network access. In this example here, we have an application monitor tool at the bottom, and that requires access to the traffic so that it can perform analysis of Oracle traffic. So you can see in the network here we have a mesh. So each of the devices has a link in between. So there are a total of 6 different network links that make up that mesh core. And traffic could be going across any one of those links. So in your traditional tool, we may need to have 6 taps, or your application monitor may need to have 6 ports in order to ensure that it's getting traffic that might go across any one of the 6 links. So that could be rather expensive for the tool. Again, operationally may not be the best way to handle that. So with a visibility fabric in place, you see that the connections, the tap points, can be established on the links, and those can feed into the visibility fabric, and your tool just requires the single link to the visibility fabric, and the traffic can be distributed, just the Oracle traffic can be distributed to the Oracle application monitoring tool. So that's an asymmetric analysis. It's something we run into quite a bit. Now if we talk about scaling that, so that was a simple example of a single tool that needs access. What we have here is more common, where multiple tools need the access to the network for different reasons, and each group will go out and obtain a tap or a span port and buy systems that collect data and feed their tool. So you're going to have systems that are now distributed throughout the network in different places. You're going to have multiple tap points, and different groups are going to be trying to share taps, and you're going to try to replicate taps and things like that. So you're going to lengths there that really increase the operational complexity, as well as create security issues, because a lot of these taps that are used with open ports on them, someone could come in and just plug their tool up to it and now have access to your traffic. So there's a lot of issues, performance, security, and just overall complexity. So what Gigamon is going to provide you is a cleaner approach to this, where the visibility fabric just requires access to the network. So you can see here in the center, the GigaView visibility fabric, it has a combination of taps, which are these orange squares, tapping the links, and port monitoring, span sessions, or really vendor independent port monitors that are coming in. So we have the purple lines and the orange lines coming into the visibility fabric. And notice the tools can now be centrally located. We don't have to have multiple web analysis tools or multiple email tools spread throughout the network. You just have all of the traffic feeding the visibility fabric, which then in turn feeds the tools. So that really cleans things up for us. And then our next challenge is, how do we get the traffic from this visibility fabric to the tools? So our secret sauce, and they're really the differentiator for us. So when you think about what's the big takeaway here on the Gigamon side, it's called flow mapping. This is what differentiates Gigamon from everyone else. We're able to feed each tool exactly what it wants to see. So I'll run through an example and step you through this instead of trying to explain this slide to you. We'll start off a little basic here. So if we just took a single port, we have a span session coming into a typical, and this would be anyone's product out on the market. This is not how Gigamon performs the function, but if you have a span session coming in, and you have tools over here on the right-hand side, and these tools need to see that traffic. So that traffic is made up of many different protocols. Well, a common approach is to take filtering at the ingress side. So this port here on the left, we would perform filtering at the ingress. So this tool number 1, it just needs to see VoIP, so we'll just send it VoIP. But to do that, we have to drop the other traffic. So all the other traffic and other protocols are filtered out, and we send it VoIP. And if that was the only tool we were feeding, this would be perfect, right? Because we'd send VoIP to the VoIP tool. But now security, tool number 2, has an IDS, so they pretty much need to see all traffic, except maybe some encrypted traffic that they don't intend to analyze, and possibly some internal backup traffic that they're not interested in. But otherwise, they want to see everything else. So if now we have to take that filter off, because if we just sent them what was already configured, they're just going to get the VoIP traffic. So you can see very quickly that this approach does not scale when you're feeding multiple tools, because this IDS and this recorder, they probably want to see almost everything. The SQL just wants to see SQL, and it's pretty much impossible to make this solution work and to scale it. So that's a common approach that's on the market. Another approach is just perform the filtering on the tool side, right? So my VoIP tool, got the same example, all the traffic's coming into the device, and I'll just send all the traffic to all the tool ports, and I'll just let the tool port decide what it wants the tool to see. So in tool number 1, it'll filter out everything but VoIP. Tool number 2, it will provide the IDS, everything but encrypted and backup, and so on. So each tool will now be properly fed. So this looks like the ideal solution until you try to scale it. Because what will happen is now I have another span source, and it's sending all this traffic, and I have a third span source, and it's sending all this traffic. So just with 3 ports, this is a very small example. If this is 10 gig, 10 gig, and 10 gig, I'm now sending to tool number 1, I'm sending 30 gig if at maximum capacity. So up to 30 gig, just going to, is that a 1 gig tool? At best case, it's a 10 gig tool. So I can't send 30 gig worth of traffic to a 10 gig port. So in this case, it doesn't scale because the traffic is going to overload the tool port. So it looked like a really good solution at first, but this is a problem. And 3 ports is just a few. So we typically see at least a dozen or more in most instances. So you're trying to feed a single tool, that becomes a big problem as well. So now we've tried ingress filtering, we've tried egress filtering, neither one work. So what are we going to do? And this is where flow mapping comes in. So with flow mapping, what we're going to do is create a map, a set of rules, which it doesn't necessarily filter out traffic, but it distributes traffic. So as traffic comes from the different data sources, the traffic goes into a map, and the rules are applied. So maybe the first map rule is that my VoIP tool wants to see VoIP. So I will identify the traffic as VoIP. And this is where we're pretty powerful as well. So how do you identify VoIP traffic? Well, different people may do that, handle that different ways. So it could be a range of UDP ports that you're using. And then in addition to that, the signaling. It could be defined by quality of service or div-serv values that you have applied to the traffic. So we can apply map rules based on really any part of the packet, very strong in layer 2, 3, and 4 headers, and also there's even some visibility into the traffic above that all the way up to layer 7. So the filtering is very powerful and can distribute traffic. The key here is where do we distribute this map rule, right? Because we need to keep performance in mind. What we'd like to do is have it performed at the ingress, right? Because that's where we're going to get our best performance. So that's what happens is you create a set of rules, very simple to create. The rules are then applied at the ingress ports, and as traffic starts to flow, it hits the map, and in hardware, the traffic is then distributed. So it's, even though the traffic comes in these physical ports, it's treated as one big map. And you can see that now the VoIP tool is only fed VoIP, the IDS is only fed exactly what it wants, and so on. Each tool is fed exactly what it wants to see. This enables a couple things. It means that when we feed a tool, we're going to feed it the traffic that it wants to see, so the tool is going to operate at its most efficient rate, right? It doesn't have to sift through packets, which does require processing cycle. So the tool is going to operate really well. And that's very important for the performance of the tool. Now, excuse me. So you can see flow mapping is the best way to send traffic, to distribute traffic to the individual tools so they see just exactly what they need to see. Now, in order to, I'm not going to get into product specifics here, but the visibility fabric, I want to show you that it does scale from the very small systems to the very large. Excuse me. The smaller systems down here on the left side typically handle our smaller networks, and they're a combination of 1 gig and 10 gig ports. And then we have medium-sized systems in the center here with a 2404, which really is a 10 gig system, has up to 24 ports in it. And we can then scale to very large networks with the high-density chassis that support hundreds of ports. A key differentiator here is this gateway layer, which is below the visibility core. So the products at the center are the visibility fabric. They perform the flow mapping and provide the traffic visibility to the tools. The gateway products just provide access to the network traffic. They are basically taps and tap aggregators. So they don't perform any of the flow mapping features that we just talked about, but they provide a gateway onto the visibility fabric. So it's important to note that distinction. The GigaView products are not taps. They are visibility fabric nodes. The taps are products that feed the visibility fabric. So that's important, because on the market you'll find a lot of taps that provide filtering and that sort of thing. So we don't want to confuse. The GigaView is not necessarily a tap. Now there are some tap blades that can go into some of the modular GigaViews like the 2404, but they are separate at the tapping function from the visibility function. So, a couple other things to take away. So flow mapping is the primary differentiator of the GigaView system. And that's what's going to provide you that instant ROI that Craig mentioned. It's going to eliminate the span contention. It's going to allow those tools to possibly remain a 1 gig tool, right? Because you could be feeding in 10 gig spans. And if you filter the traffic properly, maybe you just have a 1 gig tool out there. So you don't necessarily have to upgrade all of your tools to 10 gig just because your network ports are 10 gig. You might be able to delay that purchase a little bit. So that's important. There's a couple of other features that that can help different groups. So if you're part of a security group, one of the things we can do without getting product specific is we can feed not only passive tools, but we can feed inline tools. So if you have an inline IPS, for example, that can be part of the GigaView visibility fabric. So that traffic enters the visibility fabric, flows through the IPS and then exits the visibility fabric. Provides benefits to the tool. The IPS now has a bypass switch capability, so that if the IPS is having a problem, then the traffic can be bypassed and traffic still flows on the network. So if there's a tool failure, if the IPS fails, the network's still flowing. There's heartbeats that come from the visibility fabric to ensure that the tool is working, right? Just because the link is up doesn't mean that the IPS is processing and forwarding packets. So the heartbeat ensures that traffic forwarding is taking place through the tool. Otherwise, if it's not, it'll go into bypass mode and traffic will flow through the network but not the tool. So those kinds of products are available for the security group. Again, that's an inline, we call it the G-Secure line. It's an inline bypass switch. Also, for some of the GigaViews, we have what we call packet modification features. So these are normally when you take traffic from a span or a tap and you put it onto the visibility fabric, we don't modify the traffic in any way, we just feed it to the tool. The GigaSmart capability, packet modification, it can modify the packets. So one of our more popular ones is deduplication. If you're hooking up to a span session where you're spanning a VLAN, you're going to get duplicate packets. The same packet will have an identical copy. The tools that receive that data, that duplicate traffic, can have problems processing and identifying reporting on that, whether they're reporting on utilization or any kind of security issue or performance issue. You get a lot of false positives and a lot of extra traffic. So the GigaSmart technology, that's part of the visibility fabric, or can be, it's an option, can deduplicate packets and take out the duplicates and send them into the bit bucket so that they're not forwarded onto the tool, and then the tool can just receive a clean copy of the traffic. So that's one of the more popular ones. We also have very accurate time stamping. We can slice packets. A lot of tools, some tools can slice packets. We can slice them for you. It offloads the tool a little bit. For security, we provide masking so that if there's data in the payload of the packet that is sensitive data that you don't want the people using the tool to see that data, common example is credit card, instead of slicing that packet, we can actually mask or write over the sensitive data. So we would replace the credit card number with X's, and that data is gone forever. You can't get it back. We also have source port labeling, tunneling. Another very common one that's gaining popularity is headers. A lot of people want us to strip MPLS headers, VLAN headers. And we can also add headers as well. So GigaSmart is something that you may want to talk about. And last but not least is the GigaStream. So I mentioned that you may not have to upgrade your tools if you have a GigaView visibility fabric. The tools can sometimes remain 1 gig. If it turns out that you're feeding that tool traffic and it has outgrown its single port, maybe it's a single port 1 gig tool, if the tool supports multiple ports, so we see a lot of tools, whether they're analyzers or application performance monitors, that oftentimes have up to 4 or 8 1 gig NICs in them. So in this example, at the bottom of the screen, we have a monitoring tool that has 4 1 gig NICs. So again, instead of, if we've outgrown a single NIC, we could add all 4 of these NICs to the visibility fabric, and the GigaView will load share across the 4. So we could have 10 gig or multiple 10 gigs coming in. We are distributing the traffic with the flow mapping, so we're certainly trimming down the amount of traffic we're feeding to the tool. But if we've outgrown the single NIC, we can go up to 8 and load share across that. So you're really extending the life of the tool again, getting as much out of the tool as possible. And that load sharing can help, and it can work with the 1 gig NICs, certainly the 10 gig NICs as well. So to wrap up here, we deliver the data for all your tools and provide them exactly what they need to see. And it's going to be the most efficient system that can be provided to provide visibility to the traffic. It's secure. It's going to reduce this span port contention problem that you most likely have. Most people seem to have that. And just overall maximize the efficiency of all of your tools and better management of your budget, right? So you're going to extend the life of some of the tools and only buy the right amount of tools and the right amount of interfaces for those tools. So that sums up my portion of the presentation. So thank you very much.
Thank you, Steve. Everybody, if you have any questions, please make use of the chat function in your client. Send your question to any of the panelists. We have some time now. I'm also going to put up some contact information so you guys can. John Daughter, he's one of our BDR, business development reps. His email address is there for you. His extension is there for you. Please, by all means, he's going to be contacting each of you directly for attending today. You know, you each get an Amazon gift card, but he'll follow up with you as well just to make sure that you don't want to go deeper with this. But if you have any questions right now that you feel would like Steve's input directly, please just kind of throw it on up there, and we'll try to take care of it. I'm not seeing any questions, Steve. You might have just nailed it. That's great. No, that's great. Thanks for your presentation. Well, if there's no other questions then, Sean will follow up with each of you. We appreciate your time today. Stay tuned. We'll be doing more of these webinars with other of our partners and our own solutions in the future. Thank you for your time today, and have a great day.